from 3D truss in your exam. Okay, but now we are left only with the two things. Number one, truss with method of joints and truss with the method of sections. And about compound truss and zero force members and I mean all these things, I think complex trusses are indeterminate trusses. If you see here, we have different types of trusses. So, and we have some like zero force member, method of joints and method of sections. I put my name because I did some modification in this lecture. Okay, first of all, what is a truss? Any one of you? Yes, it's like the members. What is a truss?
The member
It's a
has a moment.
system of members.
Okay.
Usually it's not for carrying loads, right?
So, I mean, if it is a structure and it does not carry any load, I think then why we provide trusses? Like in this diagram, what do you think? It is not taking any load. The whole bridge is resting over the truss. Truss is a triangular assembly of members in which the loads are applied at joints and there is no movement in the members. Okay. I think this definition is a comprehensive definition. I'm not sure whether you will find this definition in your book, but it is an assembly of members in the triangular form in which the loads are applied at joints or at panel points and there is no bending moment in the members. So the member carries only axial forces, no shear force and no bending moment. Okay? Is it good to have no shear force and no bending moment or it's bad?
It's good to have because the main failure, like we have in structures, is due to shear.
Most of the structures we have due to beam, like in beams, we have the major failures due to flexure or shear. Okay? And in column, if the load is perfectly in the center, we have compression failure. The compression and tension failures, they are not the most dominant types of failure, but a member is very strong in tension, but it could be very weak in bending, like this member. For example, if there is a rod, steel rod, is it hard to break that rod
Yes.
or not?
Hard and
You just
tension.
have to break it, but it's well.
But what do you think? Is it difficult to bend it?
No.
No.
No. For example, if it is like 6 millimeter in diameter, 6 millimeter diameter, you can easily bend that rod by even your hand.
Completely.
But what about, can you break it?
No. Difficult.
So it's very strong. So it means the material strength is very high in tension, but material is very weak in. Now the same thing is about the concrete. Concrete is very strong in compression, but concrete is very weak in tension. So in truss, what we do, we have like some trusses in which we put a major force, major compression force on the masonry. So it has been used in the recent past and it had been used long time ago, the trusses. Okay, if you see there are many truss structures, you can find in 18th century. Okay. Well, it is one typical example of a connection, the gusset plate. Well, I should have that. I think I can show you some connections, or maybe we have, yes, like this. If you see here, so this type of connection is basically known as a gusset plate connection. Can you see this connection? Members are going from all sides, and then you provide one plate, and that plate connects all the members. We can provide boards, and we can also provide the beds. Like here, if you see in this structure, you have different parts of a truss. This part is the bottom chord. This part you can say the top chord, and sometimes we provide supports connecting the bottom chord to the column, and these supports are known as braces. We call this support as knee brace. I think you have seen these structures many times in your real life, and we call these members purlin. If you see, the load is acting only at the joints. Do you understand? If you see, for example, if you see this purlin is taking the load of roof, and this load is going to this joint. From here, from here, from here, and from here. So it means that if there is no load between this joint and this joint, there will be no bending moment. Okay? Because this point and this point, it will act as a support, and these joints, they are the pin joint, or they have only two reactions, X and Y. They don't have any bending moment. This is one example you can see here. Now we are going to discuss different types of trusses. There could be as many types of trusses as many thoughts can come in your mind. For example, if you can make some different arrangement, then it would be a different type of truss, and you can give that different arrangement maybe a different name. For example, if that is given by half, then this arrangement is known as half truss. If you can bring some new arrangement, you can give that name, your name. Okay? Pratt, fan truss, Fink truss, cambered fink. Cambered fink, why we call it cambered fink? Because we have lifted up the bottom chord. If you see the bottom chord, we have given a camber. Camber means we are going to lift some part. Camber. Why we give camber?
For bending moment.
For this.
For long distance.
But what is the benefit of cambering?
Less bending moment. No bending moment.
Maybe to concentrate the
It's like a
loads on like the joints, two joints.
Resisting moment.
It has two benefits. It increases the bending capacity, and it decreases the deflection. But in case of trusses, the bending moment is not the dominant. But in the reinforced concrete, like if you see the girders, like the concrete girders, we give a camber. Like this. So what is the benefit of this? If we make a beam like this and we provide a support, what will be the benefit?
Maybe to prevent like moments, bending moments.
So now it can take more bending moment. Okay? And it will reduce the deflection. We do this technique for pre-stressed concrete structures. It is also known as pre-stressing. So in pre-stressing, we give a camber like this. If you see, the bottom chord has been given a camber. If the span is a little bit flat or comparatively flat, we provide Warren truss. Sawtooth. If you see the shape of this truss is sawtooth. Okay? Why we provide this type of truss? Where we need natural light inside the building. If we need more natural light, then we provide this type of trusses. If you see, we are giving a full shade, the glass window here, so the sunlight can go inside the building. Bowstring. Have you seen the bowstring?
Is it an arc bridge? This one?
What is bowstring? What is bow?
Probably.
Yeah.
Any one of you who have played violin?
Violent.
Violin. So for a violin there is a bow.
Oh, the instruments.
Yes.
We don't do that here.
Yeah, I know that. But it is very difficult to play as well.
I know.
Violin.
It's extremely difficult.
So there is a bow of violin, by which you play it. You don't know the violin?
Come on.
Okay, well, so that is a type of bowstring. Well, if you don't know the violin, then I will stop here. 3-hinge truss. Now in this truss, if you see at the top there is a hinge. This truss, if there is a roller, if you provide a roller here, the whole structure can move this way. Because there is a pin. Pin means it can rotate at the top. Well, this is a bridge truss system. It's very simple bridge truss system. Well, have you seen the courses which are offered next semester? Can you see now? Okay. I'm not sure.
I haven't, but if you want me.
No, I don't want anyone. If you have seen, then it's good. Next time, I have offered one course which is known as bridge engineering. So in that course, maybe you will design this whole structure. Every component of this, like we call these beams we can call them the stringers, and these beams, the perpendicular beams, we call them floor beams. I'm not sure what they are calling here. Yeah, floor beams. These perpendicular beams, they are called floor beams, and these horizontal beams, they are called stringers. And your slab, the deck slab is resting over the floor beams. If you want me to show the cross section, I can show you the cross section here, or there is no need. For example, this beam will be the floor beam going this way, and on this floor beam we have stringers. These beams are the five beams are the stringers beam. These stringer beams are resting on the floor beam, bigger beam. And this floor beam is connected at this point. So all the load of the bridge is going to the floor beam, and from this floor beam, at these 2 points, we have connected the floor beam with a truss. Do you understand?
Yes.
So the load of floor beam is going as a vertical reaction at this point, and on the other side, on the truss vertical members. So it means now we have 2 trusses, one truss on this side, another truss on the other side, and these 2 trusses are connected from the base with the help of floor beams, and at the top we have provided bracing. So we have a bracing which is provided at the top, and we call it as top lateral bracing. Okay? Do you understand? Easy? It is a through bridge truss. Through bridge truss is that bridge truss in which the traffic is passing through the bottom chord of the truss. A truss has two chords, bottom chord and
Top chord.
top chord. So this type of bridge truss is known as through bridge truss. This is a Pratt bridge truss, so it means in this bridge truss there will be how many floor beams?
1, 2, 3, 4, 5, 7.
7.
How many floor beams in this truss?
5,
7.
How many? Yes, you. No? What is floor beam? What is a floor beam? Floor beam. I teach this or I did not teach? Are you in this class? Then where are you? I just taught floor beams. Floor beams are the beams on which the stringer is resting. Okay? So in this case there are 7 floor beams. One floor beam is here, going outside of the bolt, and in the same way they are connected on the other side of the truss. Well, truss, to solve a truss it's very easy, but to make a truss is very difficult. These structures are very difficult to make because they have a lot of fabrication, lot of connection details. You have to cut the members, you have to make the location of bolts, and then you have to assemble these members on site. So it's not that easy.
One question, Jish. What about the members that are like connected diagonally between the joints?
These members or
No. Yeah.
the horizontal plane,
Yeah.
we call it bracing. Those members which are connected in the crossway in the horizontal plane, they are known as bracing. This is how, what is the difference between Pratt and Howe?
The direction of the
The direction of diagonal members.
diagonal members.
Now this is Warren with verticals. This is Parker, bridge truss. This is Baltimore. This is one place in USA which is known as Baltimore. Subdivided Warren, K truss. Now, what are the design? Let's come to the design of. So, in case of truss members, we have either tension or compression. So, there are two types of forces in trusses. Number one, tension, and number two, compression. There is no other force. So, how to design a tension member? Do you know that? No, you don't know. Should I teach you the design of tension member? You want to know? Yes? Very simple. I'm going to give you the concept, okay? I'm not going to teach you the full detail of how to design truss. Any one of you who is taking steel design? I think no one of you, because the prerequisite is structural analysis, I think.
Yeah.
Okay, for example, there's a rod, and this rod breaks at 250 megapascal. So the strength of material we can call the yield strength. Let's suppose it breaks at yield. Let's suppose it breaks at 250 megapascal. It breaks. So this is one thing. Now you want to know how much is the diameter of this steel bar. Please remember, in design we know two things. Number one, applied load. How much load do you want to resist? Tell me. How much load do you want to resist? Tell me any value. 100 kilonewton, 200, 300.
400 kilonewtons.
400. Remember, when you say any number, you should know that what is 400 kilonewton. It is around 40 ton.
Yes.
How much is the size of one car? I mean the weight of one car?
1.5 or 1.8.
Mine is 1 to 2 years.
So I mean just imagine it is 400 kilonewton is 40 ton, around 40 ton. So around you can say 40 or 30 to 40 cars you want to hang with one steel bar. Okay.
10 kilonewtons.
Let's take like 20 kilonewton. So you want to design this rod. Now you want to make this rod is circular or rectangular or triangular or what shape?
Usually it's circular.
Okay, circular. And the material is steel and the steel breaks at this stress. So now, how much should be the diameter of the rod? 2 bonus marks. If you give me the right answer, I need the answer. If you give me the right answer, I will give you 2 bonus marks right now.
You know the diameter?
Yeah, I want the number. How much should be the diameter? I gave you 2 minutes. The material is steel, and this material you can take the strength of this material to 50 megapascal. This is the load that you want to resist. So how much should be the diameter of this bar? How much?
In meter?
Millimeters. Give me in meter.
10 millimeter.
10 millimeter. Okay, so the one guy is saying 10 millimeter. What about others?
Twelve
12.5?
10.1.
10.5?
10.1.
It's 10.01. Should be 10.01.
Okay, hold on. Now I think the time is finished. So let me do it. It's very, very simple. The stress is equal to P over A. So this is the breaking stress. 250 megapascal. Megapascal means Newton per millimeter square. And P is how much?
20 kilonewton.
20 kilonewton. So you need the area.
By R.
by R.
So once you have the area, how much is the area?
0.25 d square.
35 actually going down and we make it 480 millimeter square. Am I right?
Yeah.
So if you say it is circular, so how much will be the D? 80 into 4 or what? How much?
10.09. 10.09. It is 10.
10.1.
10.1.
Great. So it means if you want to resist this load, this is the minimum diameter of the bar which you have to provide. So if the bar diameter is greater than this, you can resist that load. This is known as design. What did you do? You just find the required diameter for a given load. So how to get this load? So this load is what type of load? Tension load.
Tension, yeah.
This is what type of load?
Tension.
Tension load. So it means that if you want to provide a square rebar, a square bar, then how much would be the size of the square?
Size.
Yes. E into N. Just take the square root of 80. It will be
Yeah.
9 something. 8.8.
8.9.
8.9.
8.9.
Okay. So
That's
this
the
is
line.
how we design. I mean, design is very simple for tension, but for flexor, it depends on which, like you want to design it for. If you want to design it for the compression, the procedure is a little bit lengthier because there is one more thing which is known as slenderness. Okay. So design for compression, we design these members for compression and tension. What do you think? This truss is stable or not?
Not stable.
No.
No. Why?
Yeah, it can be pushed.
It's roller.
It's a roller. Yeah. It can go like if you move this roller this way,
The structure would change its alignment.
structure can change its alignment. Well, I agree with you. So we have to think about the trusses. These type of structures, like what is a compound truss? Compound truss is that type of truss in which there are two and more than two simple trusses. These structures are simple trusses, and a compound truss is that truss which have more than two simple trusses. Or a truss inside a truss is known as compound truss. Do you understand? A truss inside a truss is known as compound truss. For example, like this. This structure itself, a truss. So there are three simple trusses which are joined together to make a compound truss. This is a complex truss. Can you see? Support here, and the one member is joined directly from this point to this point. Another from here to here. Now what about the stability and determinacy? It's very simple. For beams and for flexor members we have 3J. But for trusses we have 2J. Why? Because for truss members we have either X or either Y. But for beam members, for frame members, we have X, Y and Z. We have moment Fx and Fy. Do you understand?
Yes. And B.
Okay, do you want to do some problems?
Yes.
Can you see this truss?
M21, I12, R3. Which one did you Top left corner or?
First of all, what is M? Number of members. What is R?
Reaction.
And what is J?
Direction, so it's Y-axis maybe.
Now in case of trusses, we have two types.